Calcium melts at 839 degrees Celsius and boils at 1484 degrees Celsius. What is the physical state of calcium? At 1600 degrees Celsius.
Um, at 16 Celsius,
Hmm.
like
They're saying it will
what's it?
boil at 1484, like 1484.
Yeah.
Now the temperature is beyond that, beyond the boiling temperature. So what will be the
So
physical state?
it will be a gas.
Yes, it will be a gas.
Yeah.
Okay. The question is about chlorine and compounds of chlorine. First, tell me eh, in which group chlorine is.
In which
Group.
it's in group. What's it called? 17.
Yes, group number
Seven,
seven.
seven.
Yeah, group seven.
Yeah.
There in the valence shell there are how many
7
electrons?
electrons. Yeah.
Yeah, 7 electrons.
7.
Now they have asked, this question is about chlorine and compound. Use the kinetic particle model to describe the arrangement and type of motion of molecule in solid chlorine and chlorine gas.
Okay, so what's it called? Solid chlorine. The arrangement is like a regular or lattice, and the motion is like it vibrates about like a fixed position. And
Yes.
what's it called about chlorine gas? The arrangement is random, and the motion is like random as well, but it's also rapid. It can move
Yeah.
anywhere
Yes.
fast.
Yes. And they are very far apart from each other.
Yes.
Yes. Okay. Good. The graph shows how the pressure of chlorine gas. Okay, let me tell you one more thing. You see, they have mentioned that this is for 4 marks, right?
Mhm.
This question is for 4 marks. It means you have to write two characteristics in the solid, like chlorine, about the, and 2 points for the gas when it is in the gaseous form. Then they will give you 4 marks. Okay. Otherwise, if you
Yes.
have written the three properties, 3 points for solid chlorine and 1 point for chlorine gas, they will give you 3 marks. Okay. You have to always check what is the marks distribution. If it is for 4 marks and they are asking for two things, it means you have to mention two things about each thing they are asking for. Okay.
Mhm.
Okay. Now, in this, they have mentioned the graph shows how the pressure of chlorine gas changes when temperature increases the volume. Mm.
Um,
The volume is kept
like
constant.
yeah, so what's it called? The pressure, pressure of chlorine gas will increase, and the temperature will also increase.
So which this is a direct relation. This graph is telling us the direct relation. And I told you one
Yes.
more thing that at one time we only discussed two parameters, and the third parameter is constant. Just like in this
Hmm.
case, volume is constant. And if you remember the first case over here, this graph, in this temperature pressure was constant. Okay. So at one time you will discuss, if you are discussing about volume and temperature, then pressure will be constant. If you are discussing pressure and temperature, then volume will be constant. Okay. Are you getting my point? You only check, you only have two things, two parameters at one time.
Yeah.
Okay. This is the structure of the compound S. The melting point is 159. The boiling point is 200. What is the physical state of pure S at 100 degree?
Pure. Yeah, pure. Like pure sulfur would be what's it called? Solid because it's like below the melting point.
Hmm. So it will be solid.
Yeah, solid because it's below the melting point.
This is not sulfur. They have
Yeah,
mentioned that. Hmm.
I thought this was like
Hmm.
glucose or
No, this is also not glucose. This is something else. Like there are six. This is the
uh,
benzene ring, a ring, and then
6 carbon. Yeah.
there is a carboxylic group over here, and over here there is hydroxyl group, and there are double bonds as well. This is not glucose. This is
Hmm.
not sulfur. Okay,
Yeah.
this one you attempted. The where there
Yes,
is.
yes, yeah.
Okay. So in this they have asked concentrated ammonia solution give off ammonia gas. Okay, Concentrated hydrochloric acid gave off hydrogen chloride gas. Ammonia and hydrogen chloride are both colorless gases. Okay. And operator is this. Write the chemical equation for the reaction of ammonia with hydrogen. Yeah, what will be the chemical equation? You can just tell me.
and yeah, NH3 plus HCl, so it would be
Hmm. For
NH4Cl.
Cl. Yes, it will be. And what will be the state of these things? Like I can write up.
State,
Like the
like,
solid, liquid, gas. What is this?
yeah, it will be a solid. No,
Which
no,
one?
no, what's
Ammonia.
it called?
Hmm.
Uh, the nitrogen, the nitrogen hydrate would be
This is ammonia.
solid,
This is
and
this is ammonia,
yeah,
and this is ammonium chloride. You see, over here they have mentioned ammonia gas. Okay, so
yeah,
this is gas. Okay, and hydrogen chloride also this is gas. Okay, hydrogen chloride
mhm,
gas,
yeah,
and you are forming what? By the combination of
um,
this, you will get white solid. Okay,
solid, yeah.
solid ammonium chloride. So ammonium chloride is solid. Here you have to mention the states, otherwise your marks
Oh,
will be deducted. Name the
okay.
process by which ammonia and hydrogen chloride moves in the tube. Yeah. What is the name
Um,
of the process?
diffusion, yeah,
Yeah, this is diffusion.
yeah,
Okay.
because
Hmm. Yes.
yeah, because what's it called? Diffusion occurs because, like, the both of the chemicals, like,
Hmm.
spread and think
You see,
in the glass tube.
over here on this side, hydrogen chloride is more in concentration.
Yeah,
Okay. So it will start to spread out. What is diffusion? Diffusion is the movement of particles from an area of their high concentration toward the area of their
the
low
lower.
concentration. Okay. HCl is more
Yes.
here, but over here it is low. Its concentration is almost zero. So it will start moving from left to right. Okay. On the same time, if you see, ammonia is more at this position, and on this side there is very less concentration of ammonia. So what will happen? Initially there is zero concentration of ammonia, so this will start moving in this direction. Okay, so in this way they will spread out according to
Mhm.
their concentration gradients. Okay.
Yeah.
Okay, then uh, at what point A, B, C, or D does the white solid form? Explain why the white solid form at that point. Hmm. At what point this
Uh,
white solid, this ammonium chloride will form?
is it at B because, like, all of it's gonna be together? I didn't understand this question.
This was, it is based on the movement of gas. Which gas will move at a faster rate? Okay, that
Mhm.
gas will reach, and basically, if we talk about the HCl and ammonia, can you tell me what is the molar mass of ammonia?
Uh,
Like ammonia is NH3, nitrogen is 14, right? And
yes.
three hydrogens. So this means ammonia is 17. Okay, the molar
Oh
mass of
yeah.
ammonia is 17. Similarly, if we
Mhm.
talk about HCl, there is hydrogen is 1 plus chlorine is 35.5. Okay, so this will be 36.5. Which one is
Yeah,
heavy?
30.
Sorry,
30. The HCl
uh,
36.5.
HCl is heavier. Remember this thing.
Yes.
Okay, tell me which gas is lighter, ammonia or HCl?
Ammonia.
Uh, And the lighter gases can travel at faster speed, right? Their speed is
Mhm.
fast and they can cover a longer distance.
Mm.
So
Mhm.
now I have given you the clue. Now tell me
So is
where.
it gonna yeah, so is it gonna be A?
Yes, exactly. Okay. Because this will travel at a faster speed and it will cover this much distance. Then there will be formation of ammonium chloride. Okay.
Mhm.
This was
Yeah.
the question they have given you in your book as well. There is a question, similar question.
Oh, okay, okay.
Okay. The experiment was repeated at higher temperature. Predict how the result of the experiment would be different. Explain your answer. If you
Oh, if
increase the
it's like,
temperature.
yeah, if like, it will it will go faster, because if
Hmm.
we you see the particles will move faster because temperature is increased, so the reaction will happen way faster, and it will give like the particles more kinetic energy, and it will increase your
Hmm.
speed and diffusion rate.
So at what point the ammonium chloride will form?
I
Yes.
think at B then.
No, it will form at A. The
At A,
position will
okay.
remain same, but the
Yeah, because
time
it
will decrease.
always, yeah,
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 time
ammonia
will
is
decrease.
always, yeah.
Yes, ammonia is lighter in weight, so don't we sometimes we confuse that. Okay, this will form at B. This is not the case. Ammonia is, as you told, that ammonia is lighter in weight, and when we increase
Yeah.
temperature, what will happen? The the reaction will occur at a faster speed, at a faster rate. Okay, uh,
Hmm.
less time will be needed, and when less time initially maybe this reaction was happening approximately in 20 minutes, but when you increase the
Yeah.
temperature, the reaction may occur in 10 minutes. Okay, this is the difference.
Hmm.
Okay, this is they have mentioned. Okay, 3 marks, and how it is 8 marks. Okay, this is the whole. Yeah, one, one, two, three. Over here the examiner write the comments. Okay, some of the white solid is removed from the tube and dissolved in water. This is part B. White solid, what is white solid? Ammonium chloride, right?
Chloride, yeah.
They are saying ammonium chloride is removed from the tube and dissolved in water. Describe how the white solid could be tested to show it contains ammonium ions.
Yeah, this question I didn't understand.
Hmm. Basically, they are saying that firstly, what they are saying to dissolve ammonium chloride in water. Okay. So
Hmm.
what if it is dissolved in water? What will happen? There will be.
It will,
Hmm,
yeah,
what will happen?
if it's dissolved in water, it won't become like,
Hmm.
it will become like another color, or
They are saying you have to dissolve in water to release this, to release ammonium ions. Okay. To release what?
mhm,
Ammonium ions. So
ammonium
once
ions.
ammonium ions are released, okay, once they are released, basically this reaction will be like this: NH4 plus HCl. The hydrogen will combine with this one hydrogen, and one hydrogen will be with OH. Okay, like I
Hmm.
can wait a minute. This will be like this. I am writing water like this: HOH. Okay, so
Yeah.
this hydrogen will be combined with this chlorine. This is HCl. Okay,
Hmm.
ammonium is this one. What's left? OH. Okay. So OH will be over here. Clear?
Yeah.
So this is happening when you are dissolving this ammonium chloride in water. Now what they
Water,
are
right?
saying, you have ammonium ions. You have to in that solution, in that solution there is ammonium ion. How you will test whether there are ammonium ions or not? So for this, basically we add sodium hydroxide in it and we
Hmm.
heat the solution. So when we heat it, there will be a production of gas. Okay,
Hmm.
what I'm saying, that there is ammonium ions, okay, in the solution. So you will add sodium hydroxide to it. Clear?
Yes.
And you will heat this. You will heat this solution. When you will heat, there will be release of the gas. Which gas will be released? Now tell me.
What?
Which type of gas will be released when
Uh,
you have added sodium hydroxide? Ammonia.
ammonia oxide.
No, this is ammonia. This
Yeah.
hydrogen, one hydrogen will be go with this.
Uh-huh.
There will be sodium and water. Okay. This is the
Oh,
reaction. So this ammonia gas will be released. Now, how can we test this? This is colorless, right? How can you check? One thing is
by.
its smell is very pungent, not good smell.
Mhm.
It's teasing, pungent smell that is not a good
Yeah, yeah.
smell. So by this, as well as but you know about litmus paper. We add litmus paper to check the whether a
Yeah, to
solution is
check the
acidic.
colors.
Yeah, yeah,
Yeah.
exactly. So you will add the litmus paper, and the red litmus paper will be converted into blue. You know why it will
Mhm.
happen? Why red will convert into blue?
Maybe
Red.
because the ammonia gas is
Hmm.
like is like the gas is taken away, or like, you know.
This is a base. Ammonia is a
Yeah.
base. Whenever you have a base and you add red litmus paper to it, this red litmus paper converts into blue. Okay. I
Hmm.
remember it by BRB. BRB means base.
Be
Yes, base turns a red litmus paper to blue.
blue.
This is how I memorized it. Okay. So
Hmm.
whenever you have a base, you will add red litmus paper and red litmus paper will be converted into blue. Clear?
Okay. Yeah.
Okay. How about the chloride ions? How can you check? What else can we do?
Um, for like chloride, we can like add like hydrogen again in it.
No. If you want chloride ions, if you want to check the chloride ions, basically there is nitric acid. You know about nitric acid?
Yeah.
So in this solution there are chloride ions. You see there is HCl. Basically this chlorine, this hydrogen will go with this. It will form water, and you will
Hmm.
have this chloride ions, right, in the solution.
Yeah.
So now
Hmm.
you are going to check whether chloride ions are there or not. So what you will do, you will add nitric acid to the solution, okay?
Hmm.
Nitric acid to the solution and some drops of the silver nitrate as well. Okay. This is
Hmm.
a standard, for testing we add nitrates whenever we
Yeah. Yeah.
are testing the chlorides. So
Yeah.
what can be formed? You have any idea what can be formed in this? Like this is
Um.
silver, this is chlorine.
Yes.
Okay. They will combine and silver chloride will form. Okay. What will form?
Silver
Yes.
chloride.
And this is a white precipitate. Not white. This is, uh, you can say it looks like white, but it is silver in color. So by that you
Hmm.
can confirm that there are chloride ions. Otherwise, if white precipitates will not form, you will say that in this solution chloride ions are not there. Okay.
Hmm. Yeah.
Similarly for ammonia, if the ammonia will be there, what will happen? The red litmus paper will turn into
Blue.
blue. Otherwise, if it is not there, the red litmus paper will remain red. Okay. So these are the testing ways. These are the ways by which we test. And for silver chloride, but we can say for chloride ions, white precipitates will form. Okay. Precipitates. Precipitates are like
Yeah.
powder, a powder which settles
Yeah.
down.
Yeah.
Yeah. So that will be white in color. Okay. That will be white in color. So by that you can confirm that there is silver chloride. In this you don't feel any smell or like that. But in whenever ammonia is there, ammonia has very pungent smell.
Hmm.
Clear?
Yeah.
Okay. Yes. Then we have extended questions. The diagram shows the electronic arrangement in a molecule of ammonia, showing only outer shell electrons. State the type of bonding. Yeah, which type of bonding is this?
A covalent bonding.
Yeah, why is this covalent bonding?
Because what's it called? Uh, because covalent bonding is like bonding with two nonmetals, and hydrogen and nitrogen are two nonmetals.
Yes, they
So
are
like they
non-metals
share.
and yeah, they are sharing. There is. Hmm.
Yes.
Can you tell me how they both have a complete valence shell?
Because okay, if you see nitrogen has two here, and
Hmm.
it shares two from hydrogen, like uh,
Three,
four,
three with
yeah, three from hydrogen.
yeah.
Yeah,
So this is two, two,
yeah,
two, two. So these are eight.
yeah.
Initially, we know that nitrogen belongs to group number five. It has five electrons in the valence shell. These dots are
Yes.
electrons of the nitrogen. And what about hydrogen?
Hydrogen will have six electrons.
Yeah. No, hydrogen has 6 electrons.
No, it has one.
Yeah, it has one. And
Yeah,
in its shell there is one, it will share one with the
yeah,
nitrogen. So there will be, it has completed its duplet, right? And nitrogen has
yeah.
completed the octet.
Octet, yeah.
Yes. Okay, then we have hydrazine. This is hydrazine, in which there are two nitrogens. And complete the diagram to show the electronic arrangement in a molecule of hydrogen. Show only outer shell electrons. Yeah. How can we show this? You attempted this
Like you have,
question.
yes, yes.
Okay. What? Where I can add the electrons?
What's it called? You have to add the electrons on the left side of nitrogen,
Yes. Okay.
and yes, and you have to add like in the hydrogen and like in the gaps of hydrogen, you have to add one hydrogen and one nitrogen atom.
Yes. One,
Yeah.
two. Okay. And where should I add third one?
It's across here in hydrogen where the red two dots are.
Yeah. There is. These are three for nitrogen. Then fourth. Is four will be there on this position?
Yes.
Okay. What about next?
Um.
This one. Like over here, you have this one, right? Similarly,
Yes. Yeah, the
this one.
cross is in hydrogen. Yep.
Yeah. So there is this and this.
Mhm.
Now, one, two, three, this one. You put one, two, three, four, five. Okay, so how
Yeah,
many are
and there
left?
should be another
Six,
cross.
seven. Hmm.
Yeah, there should be a like what's it called? There should be another cross inside the nitrogen, the
Okay.
between the nitrogen, not across the dot, so, because it's sharing with the nitrogen.
You can also, you can. Okay, I'm clearing this. Do this. You see there is a pen option over there on your screen. There is an option. You can do
Oh,
this.
there it's
Hmm.
over where?
Annotate option is there, like this. Isn't there annotate option?
I don't think so.
Mhm.
1 second, let me just.
Hmm. See the three dots in that
Oh yeah,
actually.
yes, yeah,
Yeah,
yeah, yep,
do
yep.
this because there are some. Yeah.
Okay, 1 second. There's gonna be a dot here.
Yes.
Okay, and then there's gonna be wait, another dot here,
Mm.
and another dot here, and like another dot
Mm.
like over here, and there's gonna be crosses over here.
Cross where? Yeah, cross.
And yes, and there's gonna be nitrogen here, like
If you see this one is one, two, three, four, five, six. Okay, you
yes,
do this, then I will tell you.
yeah.
Yes. Hmm. It is completed.
No, there should be another dot here.
Yes. And yes. So
Yeah.
basically, this is what I was going to tell you, that there are lone pairs as well. These are lone pairs over
Yes,
here
yes.
and on this side. So basically, if we want to write it like this, so this means nitrogen has bonded with
Yeah.
nitrogen. Okay, this bond. Then there
Yeah.
is this nitrogen has bonded with this hydrogen. Okay,
Mhm.
then with this hydrogen, right? And over here with this hydrogen, this one, and with this one, as well as on this nitrogen there are two lone pairs, and over this there are two lone pairs. Okay, this is the structure.
Mhm.
Or you will simply see in books it will be written like this, that over here there are lone pairs. This is hydrogen, hydrogen, hydrogen. Usually we write lone pairs on the above. Okay, in this I have written on the left side. This is same. You see, both are same. One
Yeah.
nitrogen is making bond with two hydrogens. Okay,
Yeah.
because so you see 1, 2, 3, 4, 5, 6, and 7, 8. There are two lone pairs. Okay, this is one lone
Yeah.
pair, and this is second lone pair. You know what are lone pairs? What are lone pairs?
Like pairs that are like only by itself.
Yeah, they are alone. They are not making bond with
Yeah.
any other atom. Okay, and these are
Yes.
bond pairs. These are bond pairs. These are bond pairs. This is also bond pair, but this one is lone pair. Okay,
Mhm.
this one is also
Yeah.
lone pair. Okay. Uh, Over here we have nylon and protein are both polymers containing nitrogen. Name the linkage found in the polymer. This we have not done yet, right? You can skip this.
Yeah. Yeah, this one I didn't do it as well.
This one is suggested structure of the monomer used. This one is not. This is the extended
I
part.
also didn't
Hmm.
understand this.
This is
Yeah.
actually from the organic part. This is from the amino acid. Basically, this is the structure of the protein, the part of the protein,
Okay.
the amino acid. Okay,
Mhm.
we will discuss it when once we are on this chapter, inshallah. Okay, compound X is a colorless liquid at room temperature. A sample of pure X was slowly heated from -5 degree, which is below its melting point. Okay, melting point to 90 degree, which is above its boiling point. Its temperature is measured every minute, and the result are presented like this. Complete the equation for the equilibrium present in the region BC.
Mhm.
Hmm. What can we do in this? What they are telling us?
So what's it called? You have to like figure out like where what happened like X to S, so it's gonna be X to X liquid because at that
X
like
is
at
solid. You see,
B,
X is solid. They have mentioned X is
yes.
basically solid over here. You see, S. So the initial state it is solid. Now
Yeah,
what?
when it
Hmm, at BC,
yeah at BC it will become a liquid because it will melt.
they are saying the graph is -5 degrees Celsius, which is below its melting point. What is the melting point? B and C will be melting point.
Yes,
You know,
so it
if
will be a liquid.
it at the melting point, what happens is there, we say the temperature remains constant, okay? And
Mhm.
there is, yeah, this one is liquid. So we can write YL, right? Like this.
Mhm.
You got this?
I I I wrote like XL.
Yeah, you can also, we can also write
Yeah,
X and
just
L.
just just give me 1 minute.
Okay, okay.
Yes.
Okay. So they have mentioned what is the significance of temperature T degree Celsius. Yeah. What is the significance of this temperature?
T, it would be like
Hmm.
more than -5 degrees.
No, no, no. Significance T degree Celsius. This point. They are asking about this point. What is the significance of this of the temperature? Like,
Like
what is the
what will
importance of
happen
this?
is, yeah, it will make like the solid into a liquid.
Yeah, it is the melting point, basically.
Yeah,
Simple is
melting
that it
point.
is the melting point. Okay.
Yes.
What is the physical state of the compound X in the region EF? Yeah, in the region EF.
EF, it will be like get like what do we say? Like it will be a gas that's like, yeah, a gas, a vapor.
Yeah, there, it will be in the gaseous state. What would be the difference in the region BC if an impure sample of X had been used? Yeah. What can happen in the BC region if you use an impure substance?
What's
This
it called? Impure substance. Yeah,
hmm,
it
this will be like
goes
this.
like
Yeah.
yes, because the
It will
temperatures
hmm,
of it will either be high or low.
yeah, it the temperature will not be sharp. There will be no
Yes.
sharp value. Okay, it will not be fixed. That is why
Mhm.
the graph will be like this. Okay.
By the way, how do we know if it's a pure or impure substance?
They will tell you. Okay, if sometimes if you see the temperature is 90.5 to 91.5. Okay, if there is a range,
Yeah.
so this will tell you that this is an impure substance. Okay, but
Hmm.
if they have given you just 90.5,